There you go. So our free water level depth is at 5,035 feet. Okay, so yeah, so here, this free water level is at 5,035 feet. Very good. All right, so that's the second point. And then thirdly, thickness of the transition zone. All right, maybe we can call this transition like this. H for thickness, format cell, subscript. Okay, I think it's quite cool. Okay, so yeah, we need to think a little bit. So the transition zone is, of course, here, starting from here. All right, and then down to the water oil contact. Okay, here, the position where we have, water saturation greater than the connate water saturation. Okay, so that's the thing. Starting from this depth, somewhere here, down to the water oil contact. Okay, and of course, if you look at this vertical axis from this, maybe you can use this. From this location down to this location, the value that we have is the capillary pressure. So when we are asked about thickness, we need to convert this capillary pressure to be thickness, to be something like depth. And we can do that, converting from pressure to depth or to thickness. Okay, and the form of the equation will be somewhere like this, something like this. Okay, and then it's very easy. So the thickness of the transition zone should be 144. This is the conversion factor, and then multiplied by the difference in capillary pressure. All right, easily the thickness will be based on the difference of capillary pressure. The greater one should be here, 6, and the lower one, the lowest one should be this, which is 1.75. All right, the displacement pressure. And then again, to convert from pressure to depth or to thickness, you need to divide them with density, or in this case, of course, the density difference. 64.1 minus 43.5. There you go. So the thickness of the transition zone is 29.71 in feet. Something like this. Very easy, right? So the transition zone thickness is 29.7 feet. All right, very easy and very interesting. And lastly is the capillary pressure at water saturation of 50%.